Hello, my name is Dale Corsi, and I'm an engineer in the environmental department in Lansing, Michigan. And we're here today to talk about fluorocarbons, fluorochemicals. These are a class of emerging contaminants, and you may be wondering why I'm showing a picture of a beautiful waterway here to open the slide. This is a marsh in Oscoda, Michigan, adjacent to the former Wurtsmith Air Force Base. And when you look at it, you cannot tell that this is very heavily contaminated with these perfluorochemicals. And we will discuss that a little bit more in upcoming slides, but this is to make the point that you can't see these things like you can oil, and some of the other contaminants that we deal with. The purpose of this presentation is to inform our friends and our clients in the Midwest of these emerging contaminants. In Michigan, we've been investigating these chemicals since 2010, and we're ahead of the pack in ahead of the game because we've started looking for these things early in the game. We hope that what we present here today, that we anticipate that you're going to start seeing some of this, some of the concern for these chemicals coming up in the neighboring states. One of the things I want to emphasize right now is we will be discussing concentrations in parts per trillion. That's an extremely low concentration, very unusual from the more common contaminants that we've dealt with for the last 20, 30 years. A part per trillion, to put it in perspective for you, is 1 second in 31,688 years. It's a very, very tiny number. Presentation topics, we're going to talk about PFAS. What is it? The various beneficial commercial uses, the toxicology and health effects to both humans and the environment, cleanup criteria and levels of investigation, again, emphasizing that we're going to be testing, or we're going to be talking about parts per trillion. A part per trillion is 1,000 parts per billion, or 1,000,000 parts per 1,000,000 parts per million. Very, very low concentration. And towards the end of the discussion, we'll talk about Wurtsmith Air Force Base as a case study of what you can expect if you are looking for these chemicals. Terminology here. We're talking about long-chain perfluoroalkyl chemicals, which is what they had been called up until probably about 7 years ago or so. They were known as PFCs. Because this class of chemicals is so large, there's over 5,000 chemicals in this class. They're now generally called PFAS, or per and polyfluorinated alkyl substances. The two most common of this class of chemicals so far are PFOS, which is perfluorooctane sulfonate, and PFOA, perfluorooctanoic acid. During the presentation, I'll be using the terms PFOS, PFOA, or generally PFAS. And below you see a representation of the PFOS molecule. It's 8 carbons, fully with where you normally see hydrogen. We have fluorine here, and that fluorine carbon bond is a very strong bond. It doesn't break down easily. And then at the end, you see the SO3H, that's the functional group. This is what makes it the sulfonic acid, or the sulfonate. The properties of PFAS, they are physically and chemically very stable, as I just said. The carbon-fluorine bond is very strong, doesn't naturally degrade, and it means that it's going to last a long time in the environment. It's hydrophobic, it repels water. It's lipophobic, it repels fats, grease, oils. It's very mobile in groundwater. It can travel a very long distance. Like I said, it's stable and persistent. And in the environment, it biomagnifies up the food chain and it bioaccumulates in an individual animal or people for that matter. Beneficial uses. These were developed in the chemicals have been around since the 30s, but one of the most important uses was developed in the late 60s when there was a crash on the USS Forrestal, a aircraft carrier, and there was a significant fire that killed a number of the sailors and did a lot of damage to other planes and other equipment on the carrier. So the military went to DuPont and to 3M, two of the main manufacturers of these chemicals at the time, and said, can you find a way to make something better than what we're using now to put out fires? And at the time they were using fighting material that was basically water with cow blood in it to get it to foam. And it wasn't very effective at putting out a fuel fire. So the two companies, 3M in Minnesota and DuPont in various locations made these, but primarily in Parkersburg, West Virginia, came up with these foams that could be used to put out fires, and they put them out fast for a fuel fire. They're used in fabric and paper treatments. For fabric, think of Scotchgard or other chemicals like that, or other brands like that that say, you know, they prevent staining to your flooring. Paper treatments, numerous. Fast food wrappers, the Chinese containers, pizza boxes, any number of other paper treatments. They treat regular writing paper with these, and what it does is it prevents the hot material that you put into these boxes or wrappers from degrading the wrapper, so that it's still present when you get home or when you're eating the food. Personal care products. You see the cosmetics down in the bottoms there. Those are a common use for these chemicals, and they're also used in shampoos and body lotions and things like that. They were used in rubber products, cookware, coatings, Teflon. Teflon was made from PFOA. There's other brands that use a PFOS. They're used in the metal plating industry, the photographic processing, and electronics manufacturing. As I said, these are emerging contaminants. Why are they emerging? Well, first of all, we've really only started looking for them a decade ago. And where we've looked, we've typically found them. And they're concerned because the toxicological studies of these have shown that they can cause an increase in the chance of cancer, particularly testicular, kidney, and liver cancer. They can also affect the thyroid, causing thyroid disease and or thyroid cancer, which can really result in hormone disruption. They can increase cholesterol levels if you have enough of this in your body. For pregnant women, it can increase the chance of gestational hypertension and preeclampsia. And in addition, these chemicals can pass through the placental barrier and cause a risk to the developing fetus. So there's a lot of concern that these can lead to different kinds of health effects of the newborn baby. Likely sources: military bases and airports. At airports or military bases, if there's a fuel fire, they're used to put those out. And I'm sure people have heard about planes with a problem coming in for a landing. They foam the runway. That's to prevent a fire from starting from a hard landing. Automotive parts manufacturing, because you've got metal, you've got rubber, you've got fabric. All of those things can lead to contamination in their waste materials. Metal plating and processing sites. And because so many of these things end up in landfills, the leachates are often very highly contaminated with PFAS. And they're used in wastewater treatment plant, or they're found in wastewater treatment plant effluent and the sludge. So these are just a few of the possible sources. They're in just about any industry. They are used at some point in the processing. Other likely sources, like I said before, the fabric manufacturing sites, the fabrics, they coat them with these materials to make them oil and water resistant. Same thing with paper and cardboard. Chemical manufacturing facilities that make soaps, make the AFFF, the aqueous film forming foam. The rubber products, floor wax, cosmetics, hydraulic fluids, pesticides. There's just the list is almost endless. And you see the pizza boxes here. Pizza boxes were at one time coated with these to prevent the hot material that may drip off of the pizza from going through the bottom of the box, and then you have a mess on your hands. Airports, like I said, are a major source of these contaminants in the environment. They're used in fire training. Hangars have fire suppression systems in case there's a fire in the hangar. It'll put out that fire almost immediately. Crash sites and fuel sites, or fuel fires. At the Wurtsmith Air Force Base, when we talk a little bit about that later, there was a crash site there of one of the KC-135 refueling planes, and there was a very large fire put out with these. And again, the runway foaming.
Hey, Dale, we do have one question if you have a moment to answer at this time.
Sure.
Are PFAS compounds still used in material manufactured in the U.S., like food packaging, for example?
Okay. PFOS and PFOA have been essentially eliminated in the United States. However, there are over 5,000 of these chemicals in the PFAS family, and some of those, I'm sure, are still being used in different manufacturing. The problem is we just don't have any information on what their toxicity is. Each of these chemicals has a little bit different effect in an animal body or in a human body. So my answer would be most likely some of the other compounds are still used in the United States. Around the world, not everywhere has eliminated these from their processes. And distribution, perfect timing in the environment around the world. We've seen sediments in the Yangtze River in China, in Greenland, the Faroe Islands, in the Arctic in general, birds, fish, whales, seals, polar bears, all of these animals have been tested and found, in some cases, significant concentrations of PFAS in their tissue. The bottlenose dolphins in California have them. And then, again, Clark's Marsh, which is adjacent to the Wurtsmith Air Force Base in Oscoda, Michigan, has very high concentrations in their environment, in the soil, in the groundwater, in the surface water. And we will have more discussion about that toward the end. But just to give you an example, the panfish fillets in Clark's Marsh have PFAS up to 10,000 parts per billion, which translates into 10 million parts per trillion. Again, for the concentrations that we're concerned with in the human body, that is just an enormous number. Oops. In the Great Lakes, studies have been done to get an idea on how prevalent these chemicals are in the Great Lakes waters. And it's been found in all of the Great Lakes, Lakes Ontario and Lake Erie being down gradient or downstream of the other lakes, have the highest concentrations that have ranged from 21 to 70 parts per trillion. And when you consider how much water that is, that's a significant amount of contamination. And then in the Great Lakes, PFAS has been detected in all of these different water animals, the mink, trout, zebra mussels, round goby, amphipods, snapping turtles. A lot of the animals that are used for food are contaminated with these chemicals. In humans, in our blood, in the United States, a few years ago when the study was done, concentrations in human blood range from 4,000 parts per trillion to 1,656,000 parts per trillion. And a mean concentration in the study was 37,800 parts per trillion. Again, these are very large quantity concentrations when you think about at very low concentrations in your body can have significant health effects. In China, blood concentrations increased from 30 parts per trillion in 1987 to 22,400 parts per trillion in 2002. That's a very significant increase in that period of time. Afghanistan, a place that you don't relate with industrial processes. They sampled 45 people and the concentrations in their blood range from 210 to 11,800 parts per trillion. So these things are everywhere. And pooled blood samples in Europe, for the Netherlands, 53,000 parts per trillion, Germany, 37,000 parts per trillion. These are all significantly high numbers. And when we talk about cleanup levels, you'll see why this is, these numbers are very large. Government went to the two main producers of these, and 3M agreed to phase out the production of long-chain PFAS, which in this case would have been PFAS. They agreed to stop the manufacture in 2000. DuPont is currently conducting a large health assessment of residents around their plant in Parkersburg, West Virginia, both on the West Virginia side of the Ohio River and on the Ohio side of the Ohio River. And this is an ongoing study, and it was part of a settlement that came out of a lawsuit against DuPont for the way they handled waste for their manufacture of PFOA. Both Michigan and Minnesota have issued fish advisories. One of the key places is in Oscoda because that was the first place we really did a lot of study, and it's expanded since then. And in the European Union, most uses of PFAS have been banned. Regulatory response for drinking water. Again, the cleanup criteria is in parts per trillion. It's just an enormously small concentration. The EPA has developed a lifetime health advisory. It's not a hard regulated material, but this is they advise people not to drink water or use water for if it exceeds 70 parts per trillion for the two compounds combined. Michigan, on the other hand, just recently updated their criteria for PFOS at 16 parts per trillion and PFOA 8 parts per trillion in drinking water. Ohio, Indiana, Pennsylvania, they have adopted the EPA value of 70 parts per trillion for the two compounds combined. Illinois also has 70 parts per trillion for PFOS and PFOA combined, but PFOA alone cannot exceed 2 parts per trillion. And then Indiana just recently had legislation introduced into their Congress to require their health department to develop safe concentrations for drinking water. These chemicals are really difficult to remediate. They pass through most common treatment systems that we're familiar with using, that we've used for fuels and for chlorinated solvents and things like that. A lot of those processes don't work for these chemicals. They pass through wastewater treatment systems pretty easily. The options for treating these materials are very limited at this point, although now that they've become so widely regulated or researched, the treatment options, there are some new treatment options that are being tested to see their efficacy. But our challenge is we're trying to clean up to very low levels for the most common PFAS compounds. And that's a difficult task because getting something that's at 10,000 parts per trillion down to 8 parts per trillion is not going to be an easy task. Some examples of remediation in Ann Arbor, Michigan. They took their drinking water, treated it, and the Huron River was the source of their drinking water. Upstream of that, their extraction plant was a metal processing plant that discharged a lot of these materials into the river, and the health department issued a do not drink advisory for that river water. Ann Arbor was able to use granulated activated carbon as part of their treatment system, which was able to get their concentrations in drinking water below the state standards. Likewise, Plainfield Township also had impacted groundwater, but their impacted groundwater was exactly that. They were pulling water out of the ground that was already contaminated from something upstream, up gradient. And they used the granular activated carbon as well. Source removal by excavation is common, but you have to have some place to take the excavated material. So you have to be very careful that if you're taking it to a landfill, that the landfill is licensed to accept PFAS. Potable water, what we've done with potable water, at least in the Oscoda area and some of the other areas in Michigan, is we've tested probably hundreds or thousands of residences throughout the state, and where we found concentrations exceeding the 70 parts per trillion, either those homes were hooked up to municipal water sources if they were available, or a small attachment to their kitchen sink would treat any drinking water that they had. Being exposed to these in a shower or bathing or something like that is not really a problem because these don't absorb easily through the skin. Another example is in Parchment, Michigan. There was a paper mill in the area that had since been closed. And when the drinking water supply well for the community of Parchment was tested, they found very high concentrations of PFAS and immediately shut that down, brought in truckloads of bottled water for residents to pick up so they had drinking water, and looked for alternate sources of water for their community. And they were able to hook into the water treatment system of a much larger city just south of where they're located in Kalamazoo. So when you find it, you have to find out, what are we going to do with it? How are we going to take care of it? And it's not always an easy question to answer, and not always are the answers really very favorable. Now, I've mentioned that all of this in Michigan started at the former Wurtsmith Air Force Base in Oscoda, Michigan. And here's a aerial shot of the base. This is the base right here. And you see we've got the Asable River flowing here into Lake Huron. The Asable River is one of the premier, if not the premier, recreational river in Michigan. It's heavily used for fishing, for swimming, for canoeing, for kayaking, for any number of water activities. And we'll discuss later how that's been impacted by the base. Van Etten Lake is a man-made lake here. The groundwater flows this way from this portion of the base into this lake, and the lake water is has fairly high concentrations as well. And then that water also discharges through a stream here that goes into Lake Huron. Oops. Lake Huron, as I said, is also, as part of the Great Lakes, it has contaminated water, usually in the range of 8 to 15 parts per trillion when sampled. Historical use of Wurtsmith Air Force Base, it began as an adjunct to another base in southeastern Michigan, Selfridge, in the 1920s to practice snow and ice plane landings there. In 1960, it became part of the Strategic Air Command and SAC base and had over 10,000 people working and or living on the base. In 1977, Wurtsmith mission expanded to include the B-52 bombers. So the B-52s and the KC-135 refueling planes were now stationed at the base. Then in 1993, the base was officially closed under the Base Realignment and Closure Act. But the military, the Air Force, is still responsible for the contamination on the base. And they've been working to clean up various problems since 1993. And here we are in 2007, and they're still cleaning stuff up. At Wurtsmith, and this can be applied to a lot of other locations, places that we've found a lot of contamination would be landfills. There's a large landfill here and another landfill down here. Both of those have fairly large concentrations of PFAS in the water leachate from the landfill. Another major source is fire training areas. This fire training area here was a small one that was used and then eventually closed to build a much larger one over here. Those two fire training areas both are contaminated with PFAS. And you can see this one is The groundwater from this one is flowing right here to Van Etten Lake. The groundwater for this one flows right here into Clark's Marsh. So this is where we first sampled for PFAS, was in this plume here, and it's where we found the contaminated groundwater, contaminated soil, and then eventually contaminated surface water in Clark's Marsh and beyond. Was the wastewater treatment plant, because these were in all kinds of household products. Any water or any wastewater that ended up in here likely had PFAS, and we found significant concentrations of PFAS in groundwater down gradient here. There was a crash of a KC-135 refueling plane that crashed and burned here, and they went out with their trucks with the PFAS foam and put out the fire. Unfortunately, all the pilot and all the personnel on board the plane died in the crash. The hangars, and this would apply to any municipal airport as well. The hangars all have fire suppression systems in them. In case there's a fire in the hangar, you don't want the people in the hangar or the equipment in the hangar being destroyed or the people dying. So they all have these foam systems that will fill up the building in just a matter of a few minutes, and they put out the fires immediately. The problem is now you have all that foam. What do you do with it? Well, now you collect it, but in those days, they just washed it out and it went out into the soil outside the hangar. And then in the base ops area, this is where all the fueling of the planes took place, and there were spills all the time fueling the planes. So sometimes they had to put out the fires with foam. The base fire station was also in this location. So these places are typically very heavily contaminated. Now, one thing that's interesting here at LF 3031, the landfill, the leachate coming off of here is contaminated with the normal things that we look for, the chlorinated solvents and fuel constituents, but it also has the PFAS and the leachates that come off the base. In this area here is a YMCA camp that's connected to Detroit for mostly disadvantaged kids. So that's a very bad optic for the Air Force. And the YMCA camp moved their swim beach way upstream of where the water is contaminated so that the kids are swimming in clean water now. And this is just the picture of the mock-up. This is a mock-up of a plane here. They spray fuel and other flammable materials on there, light it, and then the guys practice putting it out with foam. And this is just a picture of the fire training pad with after a fire, you see all the burn there. And then anywhere that there's other fires on the base, PFAS was used. It was used in training. It was used in actual fires that needed to be extinguished. So it was heavily used on the base. And on the base, all these red areas are areas where drinking water wells were used to supply the drinking water to the residents and the employees on the base. So pretty much everywhere, these were all areas where people were contaminated. And then fish and game animal consumption. Clark's Marsh, Yasabo River, Van Etten Creek, which connects Van Etten Lake, also contaminated, down to the Lake Huron. So if you're doing an investigation, those are all kinds of places that you want to look for possible contamination. PFAS and PFOA in groundwater at the fire training area. State of Michigan for PFOS has recently lowered their groundwater surface water interface criteria to 12 parts per trillion. So groundwater above 12 parts per trillion needs to be remediated because it is no longer allowed to discharge at concentrations above 12 parts per trillion. At Wordsmith, groundwater, PFAS in groundwater typically ranges from 260 parts per trillion to 110,000 parts per trillion, obviously far above 12 parts per trillion. And PFOA in groundwater for 16 samples range from 740 parts per trillion to 33,000 parts per trillion. And again, these are high concentrations when you consider that cleanup criteria and health effects for these compounds are in the parts per trillion range, low parts per trillion range. Again, now you know why we had the picture of Clark's Marsh to start with. It is very highly contaminated water. The state regularly tests the water, captures fish to test the fish. They test other animals. I know they've tested muskrat in the past, and other animals that live in or around the marsh. In May of 2012, the health department issued a do not eat fish advisory from Clark's Marsh. No fish from Clark's Marsh should be eaten. They are very heavily contaminated. You can still fish, catch and release. You can still kayak, canoe, things like that, but definitely you don't want to eat the fish. And likewise on the Asable River. Now the Asable River is a little bit different because fish can come in from Lake Huron, but the resident fish, the fish that stay there year round, there's a ban on eating those fish. And as you see this advisory here, which are posted at all of the places where you can put in your canoes or kayaks and things like that. They just want to encourage you to say boating, kayaking, fishing, swimming are still okay. Touching the water is not a problem. It doesn't absorb through the skin very easily, but you don't want to eat the resident fish. And at down gradient of that fire training area 2, this treatment system has been installed to treat groundwater that they extract that's contaminated with the PFAS. And as you can see, these tanks are very, very large. And I don't remember exactly the amount of water that they treat per minute, but it's significant, like 250 to 300 gallons per minute. And then every couple months, they have to replace the carbon in the lead tank and then reconfigure the valving so that that formerly lead tank becomes the lag tank. But it's a complicated system. It pumps a lot of water through there, cleans it up to near zero PFOS and PFOA. And these systems are costly to install, costly to maintain, and costly to operate. And recently we found a new problem, foam. These foams, as you see here, that form on the beaches can be generated by PFAS that gets into the lakes. In this case here, these are PFAS foams. The way you can tell the difference between PFAS foams and natural foams, the natural foams are usually kind of a dingy color of gray or tan or and they often have leaves and other material from the lake mixed in with them. The PFAS foams are this bright white, they're sticky to the touch, and they're very sturdy. You can see how in some places here, the wind blew PFAS up the beach, and I've seen it where it's been the next day and it's still there. So they don't break down very easily. We think we understand why PFAS foams form on surface bodies of water. And the way we understand it right now is that the PFAS molecule likes to be at the surface water air interface. So they kind of pile up in that area when the wind blows at the right speed and the weather conditions are right. You get the water churning and it starts making the foam. And when it's making the foam, you can see pads of it or blotches of it out in the lake. And as it comes on shore, it starts accumulating like this. The health department issued an advisory to avoid the foam as much as possible because they can have high concentrations of PFAS. Obviously, they don't want you to eat the foam, but for small kids that are playing and they get some foam on them and they rub their face and their mouth, they might get foam in them. So you got to be careful about that. Since this advisory came out a couple years ago, DLZ with the Michigan Department of Environment, Great Lakes and Energy, former DEQ, we purchased and had installed a wash station right there on the beach so that when people come out of the water, they can rinse off so that minimizes any impact from possibly ingesting something off your skin. I kind of already discussed this, that contaminated groundwater vents into surface water and foam can be generated. It accumulates in the downwind shoreline, and the concentrations of PFAS in the foam are much, much higher than the concentrations of PFAS in the surface water. And again, that foam is usually bright white, small cells, sticky, whereas natural foams are dirty white to light brown and have large cells. And we have the do not swallow foam advisory and to minimize contact with foam advisory. So a summary, PFAS is an emerging contaminant. It has multiple beneficial commercial and industrial uses. It's a very, very useful product. But we've discovered that health effects have been found at very low levels in the parts per trillion range. And here you can see 1 part per trillion. There's 1,000 parts per billion. There's 1 million parts. That should be 1 million parts per trillion. So a part per trillion is very small. Like I said, 1 second in 31,688 years. It's very mobile in groundwater. It impacts soil, groundwater, surface water, drinking water. And if you're in an area where you use groundwater and there's been these kind of facilities nearby, you definitely want to have your water tested for PFAS. And cleanup levels vary by state. The EPA lifetime health advisory of 70 parts per trillion combined for PFOS and PFOA have been adopted by many states in the country. And in our region, many of the states also go by these criteria. It's really only Michigan and Minnesota that have really gone after reducing what's safe levels in drinking water. And it's because we've been doing this a lot longer than most of the other states. We can entertain questions now, but if you have further questions after this presentation, you think about things, you can contact me, Dale Corsi, at the number below. or Scott Park, also in our environmental group, and his number there is there as well. So Tiffany, if there are any questions, I can try and answer them.
Yeah, Dale, I don't see any questions in the question and answer box now. So if anybody has any questions, feel free to raise your hand. We can unmute. You can ask that question. If not, Dale, I think we're good to go.
Okay. We'll give people a few minutes to submit some questions. And again, if you have any questions, please submit them, and Tiffany will get the questions to me.
Yeah, Dale, it looks like we do have one question.
Okay.
How concerned should we be with these chemicals making it into our drinking water? I'm in Fort Wayne, Indiana. I have noticed that I have a sensitivity to these chemicals and can no longer use pans that have Teflon or certain bottled water or sparkling water.
I would say that if you have sensitivity, you should be concerned. If it was me, I would look into getting a under the sink treatment system that would take these chemicals out. That would just take care of your drinking water. Obviously, your bathing water and things like that, you would need a very large system to be able to handle that. But I actually have one of these systems in my house for our kitchen water. Goes through a system. I think not that I'm recommending this one in particular, but ours is a Westinghouse system, and it's designed to take out contaminants, including PFAS.
Okay, then we have an additional question. Has there been any attempt to clean the PFAS from removing foam from beaches?
Yeah, and it's not an easy. I actually looked into this at the request of one of my project managers at the state, and you can clean up the foam easy enough, but then what do you do with the material that you cleaned up? And that's where it becomes complicated. I tested a number of ways to collect it, but the simplest and easiest was having a small generator with a shop vac and just sucking the foam up into the shop vac. But now you've got it in the shop vac, and you have to store it until you get enough, and then you have to find somebody that can take it and either destroy it or landfill it. It's not an easy answer, and it was getting so expensive that we just decided that we would have to think of another way to protect the public. And what we've done is we've put in the advisories, and we have that wash station so that people can rinse off after they're done swimming.
Okay, a few more questions. The next one, was DLZ involved in design and or construction of the remedial system?
Not directly. We had oversight as the regulator, as the regulator's contractor, to make sure that we reviewed their design, and we didn't recommend anything per se, but we asked questions about what about this, what about that, and required the Air Force's contractor to reply to those so that we were comfortable that the system was going to do what they said it was going to do. We also did some oversight of the installation to make sure that they were following their design, and they did, and the system works. It works well. But as we found more contamination, we've had to expand the capture zone, and that has ended up resulting in more frequent change out of carbon at the facility.
Okay, is there a way to neutralize surface water foam? Is that an opportunity to remediate PFAS at the surface on small bodies of water and thereby downstream?
No, because any treatment would just put the PFAS back into the water unless you were actually extracting the foam off of the water. That's not something that we've really looked into. And so I would say right now there's just there hasn't been any research or development into something like that yet.
Okay, what are the known health effects?
Well, as I showed in that slide, they are linked to some cancers, to thyroid disease and thyroid cancer in particular. That's an important gland in the body because it's one of the regulator glands. And certainly for pregnant women, I would think it would be a major concern. If a woman plans to become pregnant or finds out she's pregnant, I would recommend limiting exposure to any of the things that would have PFAS in them, and drink PFAS-free water as much as possible, cook with it. And when you have your baby, if you have stain master on your furniture, on your flooring, you're going to have to be extra careful because those dust particles can be easily ingested or inhaled by an infant crawling on those surfaces.
Okay, thank you. Is the only known remediation activated carbon as shown as wordsmith?
No, we can also use, there are resins now available that do the same thing, and those resins you can, what's the word I'm trying to think of? You can renew them by certain backwashing techniques and things like that. You can certainly incinerate these in high temperature incinerators. I don't know how much that remediation method is used, but there's a lot of research being done now to try and develop alternate ways to treat chemicals. And then the old standby, excavating and disposing of it in an approved facility, is also another way to clean up a site. And depends on the concentrations that you have and the size of the site. It may become prohibitively expensive.
Okay, how is PFAS destroyed?
It's not. It's in nature. It's not destroyed. They refer to these as forever chemicals because once it's there, unless we do something to take them out of the environment, they're there forever. So they aren't destroyed in the environment. The only way you can destroy them is in very high temperature incineration.
Okay, just a couple questions in the chat. Will the presentation slides be available to attendees? I can answer that. Yes,
Yeah.
they will be. You can shoot myself an email at tgibson@dlz.com, or you can shoot Dale or Scott Park an email as well. We can get you a link to those PowerPoint slides. Just a couple more questions, Dale. Can you discuss sampling challenges?
Yes, I'm glad you asked that question because the sampling is very challenging because there are so many things that we routinely use to collect samples that have PFAS in them. The state of Michigan has actually developed a manual identifying what things you can use, what kind of clothing you can have on, any number of things, even the books that you're writing, taking your notes in. You have to be careful what you're using because a lot of times the books that are waterproof have PFAS. And that guide, that sampling guidance, I believe, is available on the Michigan Internet or on the Eagle website. If you do a search for it, I believe you can find it. It's Tiffany, I'll give you this link, michigan.gov/PFAS response. And there's no spaces in any of that. And that, I believe, is available to the general public. And it's a very good document if you're going to be sampling for PFAS, because it tells you all the things you can't use. And that's a lot of things that we routinely use when we're out sampling.
Okay, great. Thank you. I put that link in the chat. The last question is, are there federal state funds available for communities for cleanup?
Well, in Michigan, I know that we have some funds that are available under different programs. There have been funds made available for airports to investigate and start cleaning up. I believe there's also some for some groundwater situations, but you know, it's a state-by-state thing. I'm not aware of any federally available funds. Most of this is still done at the national level, and I believe that the previous administration nationally wanted to release funds for PFAS cleanup. I don't know if that ever happened or not.
Okay, thank you, Dale. That's all the questions we have.
All right. Well, thank you, everybody. And like I said, if you have any questions, feel free to contact either Scott or me. Thank you.